Subscribe now and click on the bell icon to never miss learning from Vedantu.
Yeah. For those of you who already know, I believe 50% of you already know, I'll teach you this in such a manner that you will never forget it. You will not get confused, because when you are in examinations, the nerves play around with you. So the concept needs to be ingrained in your mind. All right. And for the other 50% who don't know the concept, brilliant. You'll learn something today. All right. So what is the concept? Well, the trick here is, look at the acid. I am going to take a very simple example of a very normal acid, okay, which is CH3COOH. Okay, you have C double bond O, you have OH here, okay, and you here have CH3. All right, this is your basic acetic acid, a very simple carboxylic acid. Now, once it acts as an acid, what will happen is, it will turn into a species that looks like this, C double bond O. This O will give away the hydrogen and will now be left with a negative charge. This weird looking smiley is actually a negative charge, which signifies 2 electrons, yes. And then you have CH3, okay. 3 को थोड़ा प्यार से लिख देते हैं, CH3, yeah. And then in the solution or somewhere else, it would have left an H positive ion. So this particular hydrogen that was here, this particular hydrogen, the one now in a green cloud, has left and is now here. Yeah, this is what the funda of an acid is. It has acted as an acid. Now, if you have read the Bronsted theory of acids and bases, you know that we call this the acid, and we call this the conjugate base. Conjugate base. So ultimately what's happening is the acid is converting into the conjugate base. Now, when would an acid want to convert to a conjugate base? Yes. When would it want to convert to conjugate base? In obvious situations. It's a very obvious answer, that if the conjugate base is stable, yeah, if the conjugate base is stable, it would want to convert itself into the conjugate base. Yes. So if the acid gives away its H positive, turns into a conjugate base, yeah, and that conjugate base is now stable, the acid would want to lose its H positive because the species it is forming is stable. So I will write down the crux of this situation here, which says, if conjugate base is stable, acidity is high, okay, and vice versa. If the conjugate base is not stable, the acidity will not be high. If someone tells you that, hey, I have a compound called X, it is a very acidic compound, it implies that the conjugate base that the compound X will form will be stable. Yeah, chalo, ye to humne samajh liya. Now let us focus on the conjugate base that we have here. ठीक है, अब इस conjugate base में क्या हो रहा है? Let us make it here again. There is an O negative and there is a CH3 here. All right, now let me switch to a thinner black pen. Now this is a negative charge, very obvious. This is a negative charge. Now, if there is a negatively charged species anywhere in a molecule, let's say instead of just this carboxylic acid, I have this species now, which has CH2 and a substituent S. S is not sulfur, guys. Let me write some weird thing here. X. X is any substituent. X is not xenon. X is not a chalcogen or a halogen. Nothing like that. X is just a random substituent. Now, if X has electron withdrawing properties, let us assume that X is an electron withdrawing group. Withdraw. X wants to withdraw electrons. I will make an arrow in a red color, something like this. This signifies X wants to pull the electrons towards itself. Okay. So what it means is, eventually this negative charge, yeah, which is right now just on oxygen. If you can see the webcam, guys, if you see my image in the webcam, let's say this negative charge is on the oxygen. Only oxygen is trying to take care of this negative charge, but now there is an X, and this X also wants to take some share of that negative charge. It wants to withdraw the electron towards itself. It is trying to share the load with oxygen. Yes. So if the X withdraws electrons, it will make the conjugate base more stable. Understood, guys? Because that negative charge now is not just the responsibility of oxygen. The negative charge now will be pulled towards itself by the group X as well. Yeah, it could pull it in the sense of an inductive effect. It could be a mesomeric effect, so on and so forth. I'm sure you guys are familiar with those concepts for organic chemistry. Yeah, but electron withdrawing group will stabilize the acid. Now, in the other case where X is of a sort, let's make just X here, which wants to push away electrons from itself. It's like, I don't want any electrons. Oxygen, you take all the electrons. Oxygen now has a lot of load of electrons on it. Yeah, there's this tiny poor little oxygen lying around here chilling with one negative charge, and then there's this X, a new substituent that wants to push more negative charge towards the oxygen. Guys, that's not happening. So if the X group, electron donating, if the X group, the X substituent is an electron donating substituent, if it wants to push more electrons towards that oxygen, definitely the conjugate base will become unstable. All right. And now what we follow from this is that, let me take the black pen again. If I have these two acids, okay, OH, there's a CH3, CH2, and there is an X. This X is an electron withdrawing. I make it clear with that arrow. And then there is another acid, which looks something like this. And the X here is electron withdrawing, sorry. For the sake of the convention, yeah, यहाँ पे इसको थोड़ा change कर देते हैं. So the black one here was my electron withdrawing group. This one is withdrawing electrons, and the green one here is basically an electron donating group. So just for the sake of the convention of this particular page, the first one, the black species, has an electron withdrawing group on it. The second species has an electron donating group on it. Cool, follow me. Now, what's happening is electron donating group, conjugate base unstable. This is less acidic because the conjugate base is unstable, less stable. This one, on the other hand, the one on top, the black guy over here, is more acidic. Okay, because X is taking away the load from the conjugate base. Conjugate base is stable. This is more acidic. Now, okay, I have told you the idea, so on and so forth. सब कुछ बहुत कुछ बता दिया. Told you a lot of things. Now let's come to the shortcut. ठीक है. Lots of funda here, conjugate base, acid, this, that, all that jazz. Let's come to the shortcut. All right, guys. Now, wait, let me check if you guys are attentive. Yeah. Let me ask you this question once again. Are you ready for the shortcut? Come on, guys, quickly. 40% of you have voted. 66% of votes have come. Waiting a little more while, guys, please, as soon as possible. I am sure you want to know the shortcut. Yes. Closing the poll in another 5, 4, 3, 2, and 1. Okay. So all of those who have voted, 96% say yes, you are ready for the shortcut. Okay, let's go and see what the shortcut is. Now, it is sort of a way to memorize this. Yeah. And I have always solved these problems using this method. You actually do not have to even think about what the conjugate base is. Okay. So the shortcut goes on something like this. It is a memory technique. All right. For those of you who have attended my periodic table lectures, you know that I love mnemonics, and this is sort of a mnemonic that I've worked out for myself for shortcut. Okay. So the way it goes is like this. For acidity, what you want to memorize in your mind is release equals to decrease and withdraw equals to बढ़ाओ. I'll write this in English as well. बढ़ाओ. All right. बढ़ाओ means to increase. Okay, बढ़ाओ means to increase. Yeah. So all you need to keep in mind to memorize this concept of acidity of organic species: release, decrease, withdraw, बढ़ाओ. Release, what release? Electron release, electron withdraw. Okay, if you have an electron releasing group, if the group is releasing electrons, it will decrease the acidity. If the electron withdrawing group is there, it will increase the acidity. The concept you saw in the last two slides number 6 and 7, you understood the concept. Now even if you forget the concept, don't worry. All you need to know is release, decrease, withdraw, बढ़ाओ. Okay, that's how it is stuck in my mind till now. I don't even have to think about what the conjugate base or acid or whatever that jazz might be. Release, decrease, withdraw, बढ़ाओ. Simple as that. And you know what, in order to remember all of this, what you need to focus on, let me choose a blue pen over here, is this, just this part. Okay, acidity, release, decrease, khatam, release, decrease. That is all you need to remember, because if release is decrease, then of course withdraw is बढ़ाओ, right? And similarly, if we talk about basicity, yeah, if we talk about basicity, then the only thing is the order is now a bit different. This means electron release equals to increase, and if you have withdraw, this will be equal to घटाओ. Yes, and which means I'll write the transliteration and the translation. ठीक है, so you don't even need to remember this. मैं एक क्रॉस डाल देता हूं इधर. Let me put a cross here. You don't need to remember this. All you need to remember is this: acidity, release, decrease. 3 words, just 3 words in your mind. And guys, last year's NEET question paper had 2 questions from this particular concept. 3 words would have enabled you to basically gain thousands of better, a rank that is better in a number of thousands. Yeah, if you were amongst the top 10, you would have become the topper by knowing this concept. But well, the topper would already know something like this. But if you were in the general public like I was while cracking my JE, yes, and for people like us who have like normal ranks, even one question correct or one question wrong could mean a difference of hundreds to thousands of ranks. I'm sure you guys agree with me. So shortcut is acidity, release, decrease. Cool. हमने समझ लिया idea, acidity, release, decrease. ठीक है. Let's jump back to the questions that we had. Yeah, let's come here. So this fellow asks us, the correct increasing order of basic strength for following compounds is. Now, before we try to understand this question, the kinds of ways in which a substituent could donate or withdraw electrons from an organic species, those things are inductive effect. Okay. The other thing is either resonance, which is also known as mesomeric effect. I'll write M here. And then you have hyperconjugation. Hyperconjugation happens only in cases of methyl substituents, alkyl substituents. All right. So inductive effect, resonance, hyperconjugation. The types of effects could be plus I, which is inductive effect, which is releasing in nature. It could be a minus I, inductive effect, which is withdrawing in nature. Similarly, plus M and minus M, and hypoconjugation always releases electrons. So that would be plus H. All right. Plus I, plus M, plus H. Now, for those of you who are a bit confused with inductive effect, resonance, hyperconjugation, guys, it is not possible for me to touch each and every of those concepts in this tiny little class. So I definitely suggest you to stay with me throughout this class and then join the sessions, of course, because these are important concepts and you will learn about them. So, abhi ke liye, let's let me assume that you guys understand what these are, and even if you don't, I'll try to explain these questions in such a manner that you will understand. Plus means electron donating, minus means electron withdrawing. That is what you need to know if you are not familiar with this concept. ठीक है, चलो इस क्वेश्चन को सॉल्व करते हैं. Let me take a red pen because the question is already sort of black. ठीक है, so now if we see the first one, there is no effect that is happening, so I'll write NE. No effect for the first one. If I see the second one, options को side पे कर देते हैं. If I see the second one, what are the effects that are playing in? Guys, can you tell me what are the effects that are playing in? Please write it down in the question or chat box what you have. Okay, yes, lot of correct options coming from you guys. That is good. So basically what is happening is NO2 is an electron withdrawing group. It exercises a minus M effect and a minus I effect. Okay, it has both an electron withdrawing resonance effect and an electron withdrawing inductive effect. All right, so minus M and minus I are playing here, highly withdrawing. ठीक है, फिर उसके बाद आता है अपना the one that has a methyl substituent. Now what is happening in CH3? Basically just a plus H effect. It is releasing via hypoconjugation, and also a slight minor plus I effect also exists in case of an alkyl group. ठीक है, so we have one no substituent, we have one in which things are being withdrawn, we have one in which things are being released. Now acidity, release, decrease. Here it is asking basicity, which means release, increase. ठीक है, so the highest basic strength in this case would be for the one which has the most number of electrons being released into the system, and that one is this. Okay, basicity, release, increase, because acidity was release, decrease. Yeah, so release, increase, which means 3 is the highest. Which one out of these options has 3 as the highest? Already solved. Simple as that. Now you must be wondering why this question looks a bit odd on the whole scheme of things. The background is white, this is a bit not so white. Yeah, this question was asked in NEET 2017. All right, just by knowing acidity, release, decrease, you solved a whole question. Brilliant. I hope you guys understood this particular question. Now let's move on to the next question. This one asks you the order of the pKa. Now to understand pKa, guys, it is again a long concept. I won't tell you everything here. Just listen to this. More the acidity, lesser the pK. I'll write it here. More acidity equal to less pKa. Okay, because pKa is the negative log. P basically means the negative log. It is the negative log of the rate constant of the acid reaction. Okay, when an acid is losing its H positive, this is a reaction. The rate constant that you have, if it is higher, the thing is more acidic. But if you take the negative log of this rate constant, the lower the pK is, the more will be its acidity. Okay, so more acidity equal to less pKa. Always take care of this particular thing in your questions if they ask pKa or if they ask acidity, because you can definitely do a lot of silly mistakes in this area. All right, so अब इसमें देखते हैं. पहले let's see what the acidic strength is, and then we'll invert it to get the order of pKa. All right, so in first case, what is happening is you have fluorine. Okay, this has a minus I effect. Guys, this one here is a carbon that is sp3 in nature. Yeah, so mesomeric effect will not take place at all. Yeah, because mesomeric effect needs an sp2 or an sp carbon to be in between. This one is an sp3 carbon. There is no point of a mesomeric effect at all. Only thing that you need to worry is the substituents, and the substituents are all in all inductive effect in nature. Yeah, so first case, fluorine, highly electron withdrawing. I'll write an exclamation mark here because it is highly electron withdrawing. Then you have OH. All right, OH is also electron withdrawing, but as you all know that fluorine has a higher electronegativity compared to oxygen, so the minus I of OH is not that much. That's why I'm writing just a minus I and not an exclamation point over here. Then moving to point number C, there is no substituent, no group, nothing. Okay, and then If I move on to the D part, yeah, again this is an sp2 carbon, guys. There is no point of hyperconjugation using this because it's an sp2 carbon here. If this were to be an this is an sp3 carbon here, pardon me. So this one is an sp3 carbon here. There is no point of hyperconjugation happening on an sp3 carbon, yeah. So if this was an sp2 carbon, the hyperconjugation from this group would have been applicable. Right now it is not. All we need to see is whether it is plus I or minus I, and as we all know, an alkyl group is weakly plus I. ठीक है, थोड़ा सा it has a releasing effect because of the tiny difference of electronegativity between hydrogen and carbon. ठीक है, so high minus I, थोड़ा सा minus I, no effect plus I. Acidity में release is decrease, withdraw is बढ़ाओ. All right, so release decrease में सबसे कम होगा, withdraw बढ़ाओ में सबसे ज्यादा. So the highest acidity is A, then you have B, then you have C, and then you have D. This is the order of acidity. ठीक है, D is the least acidic because D is the least acidic, yes, because it is a electron releasing group is acting here. Yeah, release, decrease, withdraw, बढ़ाओ, right? So acidity का ये order आ गया. D is the least acidic because it is a plus I effect, release, decrease. Now the order of pKa will be opposite to that of the acidity. Yes, so the answer now becomes this one. 2 is the correct answer, and 50% of you did get it as the correct answer. So great job, guys. ठीक है.